Okay. Hello everyone. Hello everyone. My name is Chris Adams, and you're here to listen to me talk about planet-friendly web development with Python. Now, my name is Chris Adams. I'm Mr. Chris Adams online, pretty much everywhere. Um, I've ended up kind of calling myself an environmentally focused web generalist, largely because I've been working in a number of different fields over the last say 10 years, 10 years of my life as a professional developer techie person. All right, so I started out programming in Django in 2008, but I've worked as a designer, a system administrator, a product manager, a user experience consultant, a user researcher, and a Ruby on Rails developer, and a Drupal developer, and a WordPress developer. So worked in various roles. And in most of the time, I've been working on kind of environmentally minded projects. And over this time, I've ended up thinking a fair amount about how what we do as developers relates to the wider discussion about the environment and climate change. That's kind of wider than our world, really. And my aim today is help to provide some context about how what we do fits into the wider picture, but also share a mental model with you for thinking about building apps with this in mind. And then I'll try to make this a bit more concrete by pointing to some specific techniques or some specific libraries that you might want to be able to use. But I'm going to be mentioning carbon dioxide a few times today, and I figured it would be useful to provide a super quick reminder on the greenhouse effect, just so we're all on the same page. So hopefully this diagram is going to give me a hand. So this is the sun here. The sun sends loads of energy to Earth, which is useful. Some of the energy warms the planet, which is kind of handy. Some of it bounces off, which makes Earth visible to everyone else. However, what's special about the Earth is that in our atmosphere we have lots and lots of gases which bounce some of this energy back into the planet. Now, this is pretty much how a greenhouse works, so it ends up being called the greenhouse effect. And this is actually a very, very useful thing to have. Like, without the greenhouse effect, we wouldn't have actually had life on Earth in the first place. So it's been kind of useful in that respect. But over the last 100 years or so, largely as a result of human activity, we've ended up with greater levels of greenhouse gases in the atmosphere, in particular carbon dioxide, CO2. Now, more CO2 results in a more powerful greenhouse effect, which results in more energy in the system, which results in a warmer world. And a warmer world does sound nice, especially when you look outside in the lovely weather we have today, but the reality is rather less nice. It kind of means more things like extreme weather events, drought, massive destruction to vital ecosystems that we rely on, and in general, problems of the kind that scientists describe as existential threats to civilization, and ones that can only really be solved by collective action as an entire planet, really. So, since the mid-90s, we, and when I say we, I mean like the United Nations, not me personally or people I've worked with directly, we've been meeting every year for a series of huge long meetings to agree on what to do about this aforementioned existential threat to our civilization. And after 22 years, we've actually, 22 goes at getting it right, we actually had some success in 2015 in Paris. More or less, everyone agreed that we definitely want to limit climate change, and we definitely want to aim for less than 2 degrees of planetary warming from where we are now. Now, this effectively created a ceiling on the amount of greenhouse gases that we can emit as a planet, a kind of carbon budget. And like, if you can see, there's a kind of curve here over the last, say, 50 years. We need to kind of change to kind of go something a bit more like that. When we get to blue, we're safe. So we don't have that long, really, by the looks of things. And the thing is, if you've been in a long meeting with more than 3 people, right, you might think I hope you'll appreciate how much of an achievement it is to get an entire planet's worth, entire United Nations worth of people to agree to anything. What's more amazing, though, is actually people are starting to follow through with this agreement, and they're changing how their economies work. So according to the International Energy Agency, that's the people at the bottom, 2017 is the third year where global emissions didn't actually increase, but the global economy continued to grow. So we're seeing a decoupling of the economic growth from emissions, and we can now point to this happening in both America and China, like the 2 largest emitters, making up like around half of the world's emissions. So we're seeing their emissions fall while the economies have been growing. And while this does sound great, we do need a sense of perspective because it's taken this long to actually get to this turning point. We really need to reduce our emissions much more aggressively than we did just to say a few years ago. And this blue line here, you see here, which is relatively gentle, that's kind of how things would have been like in maybe say the early 2000s, late 90s. Now we're further along. We need to make a jump more like that, which is much, much more aggressive. And that is that needs like kind of a massive effort just planetarily. And I figured it might be useful to kind of give some perspective here to see where we fit into this. So this extremely complex diagram is a breakdown of global emissions, roughly by sector, and that's the bit in the middle which you probably want to look at the most, really. This stuff here is showing what the main sources of emissions might be, and you can see it's generally coal, natural gas, and oil, these things being burned, and down here is direct emissions, which is often things like, say, farming and so on. So, but I wanted to draw your attention to this part here, really. So you can see agriculture, which is like tied to kind of meat production. That's about 7%. Transport, like flying around by or traveling by train, traveling on roads, that's about 15%, with roads being about 10%. Down here, land use change. That's a kind of euphemism for deforestation. All right, and you can see that. Well, where's IT? Where's what we do? Well, we're kind of bundled in somewhere around here, but we don't even show up on the radar. All right, show up on the chart, and this is one of the key things to think about when talking about climate change in the environment. If you woke up tomorrow and you thought, I have to do something important about climate change, you probably wouldn't start with how you design your websites. You know, you'd start with things like what goes into our diet, how we travel, and there's all these things there. But I'm not here to talk about that. And that's far beyond the scope of the time I have. I'm here to talk about our impact as we build websites and web apps and so on. And this is me citing. This is a deck. This is actually, if I'm citing a report from the Climate Group Smart 2020 report, they were kind of showing that we do actually have some impact. So within that kind of graph there, in 2007 we were about like 2%, right? So 830 million tons of CO2. That's about the same footprint as Poland, basically. So an entire country's worth of CO2. And the thing is that we're growing pretty quickly. So you can see that although we were listed as 2% in 2007, in 3 years' time, we're listed to be something more like 4%, which is like twice aviation. So we may have started quite small, we're growing pretty fast. And as web developers, while we might not have direct control over deforestation, we have rather more control over how we might use data centers and the infrastructure for delivering our applications on our websites to our users. So I've been trying to come up with a way to think about this that can help inform how I design my websites, and I'm going to share it with you today. And I think there's a lot of overlap between what's good environmentally, also what's good just general good practice for building kind of products and services online. And I think it's an interesting lens through which we can look at what we do. So I've grouped this mental model into kind of 3 main areas. So your servers, your packets, and your process. So in many cases, this is I'm trying to kind of borrow ideas that already exist in other domains of expertise. So for your servers, we might be thinking about traditional things like, say, software engineering, performance optimization, technical architecture, and ideas and lessons learned from the DevOps movement. For packets, we'd be borrowing ideas from web performance optimization and usability. And for process, we borrow ideas from, say, like the lean UX movement and people who are working with continuous delivery. Now, there isn't really time to cover that, which is why I've grayed it out. But there's a link at the end of this to a 45-minute talk which I've given about that section. So I'm going to start with your servers. So when it comes to servers you control, you can think of 2 main kind of impacts you might have as a developer. All right. First one is your provider, where you get your power from, and the other one is provisioning, how you might actually use that kind of power you have. So as I said before, it's worth asking, where does the power come for the servers that you're running? And this is where you probably have the most direct control. Now, a few years back, if you wanted to run web apps on renewable power, you could run them in Iceland because Iceland's full of geothermal power. Really, really, really steady grid, not too expensive. Or you could run with some much, much smaller providers who run things on, say, solar panels and stuff like that. But in many cases, they either weren't very reliable or they didn't have a very kind of, they had quite a limited product offering. So if you're used to having like Heroku or hosted databases or all these lovely things, you're going to be out of luck. However, these days, you're much less likely to make this trade-off in between green and effective, really. So you don't have to give away that competitive advantage if you're working and you have competitors building other things like you, right? So in Europe at least, if you're using like one of the two cloud giants like Amazon and Google, if you're running on their infrastructure, you're already running on renewable power. So that's without even thinking about it, you've made a pretty green choice. Now, this is mainly for Europe, okay? So in America, if you're still running on stuff, if you're still running with Amazon in America, you're still burning loads of coal and you're still kicking out loads of CO2. So try running it in Europe if you can. Or run it on the west coast of America, which is full of like dams and geothermal. And then you're back into Captain Planet territory, all right? So the other thing you can do is about how you provision, how you use the resources that you purchase. So the thing is here is that, well, if you think about how we actually, if you think about how the internet like uses how we all use the internet, we don't have a kind of flat usage graph, all right? So this graph here is basically showing the kind of like usage patterns you see online. So around about midnight, everyone goes to sleep, so no one uses it. And then we wake up, and then as we wake up, we use the web at work more. And then when we go home, we all watch Netflix, so it goes back up again. And then we all get tired and we go to sleep. All right. So this is kind of we can take advantage of this. And if you're used to, for many of us, we're used to paying for compute by the month. We might just buy a host and think, well, it's going to be like, say, between $5 and a few $1,000 each month or euros each month, and that's the end of it, right? And we don't really think, we just think about making sure there's enough headroom to kind of have that spike of traffic rather than kind of making use of, basically matching our resources to the usage patterns. And if we're thinking about the environmental impact of wasting all this unused capacity, I think there's a missed opportunity there. It feels a bit like kind of leaving the lights on at work when you go home for no good reason. And for the longest time, because provisioning servers has been really, really slow and has been a real hassle, it has made sense just to leave the lights on when you go home, because the cost of managing any kind of spinning up servers and switching them off again has actually outweighed the cost of any kind of savings you might make in terms of cash savings or environmental savings. But I think as we've started to use services rather than servers, this has changed. So if we shift to using like platform as a service, things like, say, Google App Engine, Heroku, or say Cloud Foundry, we start to we make a trade-off. We trade off a higher unit cost for an easier kind of experience to kind of spin servers up and down and scale down as well as up. And if we're looking at this through our planet-friendly lens, this is actually kind of useful because it means that we can scale down the compute we have at periods of low use without that much cost and without that much, basically without that much effort. And increasingly, you don't even have to think about this stuff. Some of this stuff is actually done automatically now. So if you're using Heroku or if you're using, say, Google App Engine, there are actually auto-scaling tools. But if you're not sure about using auto-scaling tools, there are actually ways you can just kind of run this on a timer now. So if you're using Cloud Foundry, you can literally just say, spin down most of my servers after a certain time, and then spin them back up again around 8 or 9 in the morning. And Heroku has the same thing. There's a thing called light switch. If you get a spike, it can reprovision them, but on the whole, it just switches them off. And that means you're using less compute when no one's using it, which I hope you'll see is kind of useful in terms of cash, but also kind of planet-friendly too. But there are other models that are coming onto the market that we might think about as well. So there's this phrase called functions as a service here, which is also known as serverless sometimes. In this case here, you pay probably somewhat more per unit, but you don't really think about scaling at all. You're not thinking about having, say, redundant servers. You're not thinking about having servers in multiple locations in the same way. And you're not thinking about things like failover. In fact, most of this stuff is kind of, the idea is that we'll take care of it for you. Now, you still need to think about this, obviously. And there are lots of other things to take into account here. But it's worth it. It's quite an interesting model because it kind of changes how you think about how you purchase these resources and actually how you use them. So this is a quote from, oh God, I don't know how to pronounce that guy's name, Gojko Adjik. So he wrote a bit about serverless, and he said like why it's interesting. And he talks all about the operational sides of this, like how it changes how you deploy things, how it changes how you version APIs, and all this stuff here. But this was one thing that really kind of stuck out at me. Like, this is one of the first times where there's such a clear incentive to run really, really efficient code. And this is partly because when you use any of these functions as a service or serverless tools, you basically pay per 100 milliseconds of use rather than per month. So that's immediately much, much finer grained access. But also, you just pay for the RAM. So it's the milliseconds of use multiplied by the RAM used for that server just to serve that particular request. So if you can actually improve your code to service the same request twice as fast, you've halved the cost of that. And if you've managed to find a way to serve that in half the RAM, you've then quartered the cost of what you were running before. So this is like quite a win, and also makes you looks like a rock star in front of your boss. All right. So in many cases, less CPU burned means less money spent. It means less CO2 released, and that means like this is like a really good argument for performance optimization on the server side. All these fun tools that you've been hearing about, now you have like a moral, planetary, good reason for using them. So that's I find that kind of fun if no one else did. And you might be wondering why this talk is starting to feel a bit sound like it's about optimization. It's because what it is. So, like I said before, there's a lot of overlap between things that reduce the CO2 emissions we make and good engineering practices. And this is one other thing as well, actually. So, Google and Amazon, they don't necessarily care about saving energy because it's like the nice planet-friendly thing to do. They're doing it because it's good business sense, and they work at a scale where the incentives to save their energy are proportionally greater than what we might actually have. So they can use much more sophisticated techniques to run their data centers greener than we might be able to, or than lots of other companies might. So to give you some an idea of this, Google actually have an AI, DeepMind, basically running machine learning constantly on how they run their data centers, tweaking various settings around them to reduce the energy that it takes to run this stuff. And they've been able to kind of reduce the emissions by reduce the energy and therefore emissions by something like 40%. Now, we tend not to have that kind of resources to actually apply that. So I think there's actually something interesting there as well. So in this case, planet friendly is kind of wallet friendly in this case. So if you're working with Python, there are a few tools that you might want to look at. So Cloud Foundry is a bit like an open source version of Heroku. It's usually it's about half the price if you kind of get it from Pivotal, who are like the biggest providers of this. But there are lots of other providers as well. I think in Berlin there's one user. There's one provider called, I think it's Any9s, and Heroku. Some of you may have heard of Heroku. All right. Now, if you want to code things in Python, there are kind of two options available to you. Chalice is a kind of it's a Python library, which is the official library from Amazon, which makes it quite easy to use. So you basically like define method. You write a very, very small method. It's like even smaller than Flask, all right? And you are very, very tied to Amazon's entire stack, but it's really, really convenient. It's quite a nice experience to use. Now Zapper is the other one. Zapper is a bit more like the general kind of proposition from Zapper is if you already have a Python application like a Django app or a Flask app, you can just convert that and that pay per resource rather than paying all the time to run servers. Now, of these two things, Zapper is less tied to Amazon, so they're trying to have some kind of abstraction from this so that they could also run on, say, I don't know, like say Azure, Microsoft Azure or Google Cloud Functions, but but it does feel a little bit more magic than Chalice might, so you can make your decision there. So I've spoken a bit about your servers. I'll talk a bit about like your packets, because basically when a request leaves your service, you don't have that much control about how it gets routed through the web to reach a user. And this is a feature of the internet, and is usually a good thing. However, because you don't have control over how green the infrastructure is, you don't have control over the CO2 emissions there. Now, this map here is called the electricity map, and this shows how green the electricity is around Europe on a kind of minute-by-minute basis. And it basically colors different countries in based on what kind of energy they're using. So France, full of nukes, is green. So England, which runs on loads of gas, is kind of orange. Ireland has loads of wind, so that's kind of green. So Spain is sunny, so therefore it has loads of solar. Up here, you've got all the kind of Nordic countries. They've got loads and loads of mountains and loads of hills, which means they have loads and loads of hydro, which is very, very green. And then in Poland, where they love coal, it's a really dark, dirty black, basically. So they're like 2 or 3 times the intensity of most of the other countries here. And we don't have control over this, but there doesn't mean that we can't do anything about this. So I've told you a bit about kind of like the energy used in like how kind of carbon intensive electricity is. And that's something we can't control. We can't actually control either how people access our websites. So previously, you would have thought that people use like say Wi-Fi and like wired connections, but it's much more about accessing things over 4G these days. And the thing is that 4G is much more energy intensive than 3G or previous kind of wireless connections, really, which means our CO2 emissions increase here as well. And to give you an idea, like this is again from this report called "The Power of Wireless Cloud," and you'll see like in their best case scenario for 2015, we saw something like a threefold change, and then the more realistic case is more like say 4 times. And you can see how much of this is made up by 4G now compared to like say running servers or just running things locally on Wi-Fi, right? So this is one thing, but what makes this even worse is that energy, like web page sizes, keep increasing. So this graph here, taken from this website here, shows the kind of trend. And you can see how basically images keep getting bigger and bigger and bigger, and we keep chunking more CSS onto, more JavaScript onto every single page. And now we're putting video onto here. So the average page now is like, more like 2.1 megabytes. That's longer than War and Peace, all right? So like this is kind of not a great thing from an emissions perspective, but the thing is, we can see what's causing this, and not only does this create a kind of planetary impact, it also has an effect on user experience. And inside the kind of UX community and also the web performance community, they've introduced this idea of having kind of performance budgets, which basically say the page won't be bigger than this than a particular size, so it can load quickly. And if you want to do something like this website here is really handy for it. Webperformancebudget.io. You basically say, I want my site to load this fast on this kind of connection, and it gives you a budget. It says, okay, you've got 500K on images, 200K on JavaScript, and so on. And the thing is, that might be good for the actual designs, the design phase. But how do you keep track of this? There are tools out there that can help you with this as well. One of them is called Speed Curve. Another one is called Site Speed. And what these do, they're a bit like kind of continuous integration, constantly checking the performance of your website to see how quickly it takes to render a page, how large they are, and how much of your kind of images budget you might have used here. So you've got a way of kind of keeping track on this. And this is actually used, yes, to kind of check your performance, but it's also a really handy tool for benchmarking your site against another competitor. In fact, Uswitch, who are a very, very large energy switching company, they brought their page down to something like 600K in size. So they loaded something like 5 times as fast as their competitor, and they just made a huge amount of cash on having such a fast, nice loading page. Speed Curve is proprietary software, but it's very easy to use and it's like free to start. Sitespeed.io has like Docker containers, so you can just run it yourselves, but then you're running your own servers, and that can, well, good luck. So the other thing you can, so I've spoken a bit about that and like giving you some context, things you might actually do. So in many cases, when you send a page to someone, it's quite common to just get all these things you don't actually need. You might get a whole bootstrap's worth of CSS when all you care about is just a little bit of typography, or you might get a whole jQuery's worth of JavaScript when you only care about a few pieces of functionality in there. And like, as developers and designers, we can make decisions there. We can make kind of what I call lossy trade-offs, right? Where we decide not to actually have some functionality, and so we have a fast loading, better user experience. And I think like this is not a particularly new concept. So this is not going to be kind of news to anyone. The other option is kind of lossless changes, like how efficiently are the bits being sent. So you might think of things like, this is where you might fit kind of compression or caching into something like this. And this is, when I gzip files or when I minify them, I'm not changing the functionality or all the potential things you could do. I'm just making them smaller and get transferred quickly. And that will usually have an impact on reducing the size of the pages that I send. So if you're working in Python, there's a few tools available to you. So if you're working with Django, you get loads of this stuff out of the box for free. Flask, you need to have some external tools. I'm not going to talk about all the Python things because there are just too many to keep track of. So I'm referring to dynamic as things that have been created by a running process here, a running Python process. Static might be things like the JavaScript you generate here. Now, if you're using Django or some other thing, white noise is similar for this. if you're using CDNs, this would be a common tool you'd be using, which take care of compression in many cases, or caching. I've kind of broken these down into like basically lossless and kind of lossy stuff, really. And likewise, if you've got dealing with uploads, you can take options here. Now, in this section here, like things like Webpack 2 or Google Closure Compiler, what they'll do is they'll look at your JavaScript and they'll kind of optimize it by basically looking at which the paths that your code is going to take, and then get rid of everything else, which is kind of why it's lossy. And if you're looking at images, Nginx does something like this with images for you. So you can actually kind of compress images yourself. But Nginx, there's an open source module called Mod PageSpeed that was released by Google. And what that does is that actually basically takes your images and intercepts them being served, makes optimized smaller versions of them, and serves those in future and caches those instead. Like, you can just run it on your own server quite easily. Otherwise, there are various CDNs which take care of some of this. Now, if you want to have images coming in, if you want to work with images, right, this mod speed does that for JavaScript, but also does that for images. Now, if you're working with easy thumbnails, which is a common library, there's actually an extension called Optimize, and that just basically takes in an image, makes some changes to strip out some metadata, again, reduces the size of it, sometimes by up to like 40%. And if you're working with, like, say, local static files, and you're like developing with, say, OS 10, then Image Optim will basically take all of your existing images and shrink them in your development process. And likewise, Trimage does the same thing, but for Linux. So hopefully this has given you some idea, giving you a better understanding of what we do as developers, and how what we do as developers fits into the global picture, and how some stuff you might already be doing has an effect on the environmental impact of the sites and apps you create. Now, remember those scary graphs I showed you in the morning? We've got so much more that we need to do, but as developers, this is one thing we can do straight away. And also, if there's one takeaway I want you to take from this talk, it's that making a website work better for the planet is pretty much the same thing as making it work better for users. So the chances are many of you in this room already are planet-friendly web ninjas in this stuff. You already know how to do this stuff. So I hope in your day-to-day jobs, you'll see some things that you already know how to do can help make the sites you build more planet-friendly, as well as cost less and provide a better user experience, making you look awesome in front of your boss, as well as feeling like a regular Captain Planet. So I'll end this talk with a quote from one of my favorite childhood cartoons. The power is yours. Thank you. If you're interested about this, sorry, just 2 seconds. I've set up a mailing list where I'm sharing with this stuff here. So if you want to look at this, there's just like a newsletter. I'll be very, very considerate about your time, but I'm trying to like learn as much as I can and share some of this with you. And if you would like to learn more, sign up there, and then you'll get more information from here.